Hi guys, my name is Andy Flores, and today I'm going to be introducing my automatic water dispenser project using Arduino. Now, Arduino I have is a Arduino Uno R3, whichever one will suffice. There's actually 5 main parts of this project. Part 1, the solenoid valve. Part 2, the Arduino Uno R3 and its breadboard. Part 3, all the PVC fittings here and here. Part 4, the water bottle. And part 5, which is one of the main parts, but it will be using a HCSR-04 ultrasonic sensor. Now, what the sensor does is measures distance of an object when it's in front of it. Now, I say it's the most important part because it's going to be basically telling you when there's an object, allowing the solenoid valve to open. Now, let's go over part 1, which is the actual solenoid valve. The one I have is a 12-volt valve, which is typically normal or standard. It has a 4.8 amps or watts used to power this. Now, how it works is basically mine's originally closed. Now, what that means is that no energy by itself is closed, but once the energy is introduced or electricity is introduced, it'll open. And since this solenoid valve is programmable, we can use the Arduino program to basically communicate with the sensor, and we can tell it to open whenever there's an object in front of it. And that's how the automatic water dispenser works. Now, going with part 2, the actual circuitry. Now, what we have is the actual sensor connected to trigger 9. Now, pin 9 is connected to the trigger, and pin 8 is connected to the echo of the sensor. Now, what that means is that it's one part of the sensor that allows to communicate information. The second part is that we have the sensor connected to ground and sensor connected to the 5-volt pin. Now, that allows for the sensor to actually get power from the actual whole system. Now, what we have here is the bin pin, which is connected to the positive terminal over here, and the ground pin, which is connected to the negative terminal over here. As we can get a closer look, we have the one I'm using is a IRF 520 channel MOSFET, which is over here. Now, this MOSFET has 3 pins. It has the gate, source, and drain, which here would be gate, source, and drain. Now, the gate terminal is connected to a 1K resistor, and that is connected to a 10K resistor, which is then connected to a negative input right here. Now, we have a jumper wire connected to the source pin. Now, this jumper wire is used to be connected to the solenoid valve. Now, my solenoid valve doesn't have a positive or negative terminal, which is great because you can just switch it around. And then last but not least, we have a drain, the drain terminal. That is connected by this red wire to the negative terminal right here to drain power. Now, we have this green wire, which is connected to the positive terminal, which is then connected to the solenoid valve. So as you can see here is yellow wire connected to one terminal and red wire connected to the other terminal. Part 3 is the PVC fittings, which is basically a half swivel part connected to here in case you guys want to put a piece of tubing or a piece of plastic tubing, just to make it easier so you can get an easier output, easier pour. the actual solenoid valve itself, a 3/4 adapter, and then a 3/4 male part. That is needed so we can input or put any water bottle or soda bottle that you guys have. We decided to go with 3/4 because usually the standard for water bottles or soda bottles has a 3/4 opening and not a 1/2. That's what we hear. Plus, this is also a 1/2 opening, so we can get a good fit. That's how it works. Now, right now it's not connected, but we will be using a 12-volt adapter. As you can see here, mine has different types of connectors, which is connected to that 12-volt adapter, which is running on 110 volts to 120 volts with 60 to 50 hertz, which is how the 0.5 watt. It's not connected right now, just so I can show you, and also we have liquid involved, so we just don't want to mess it up real quick. But for the next section, we'll be showing you a demonstration, and I think that's gonna be it. Hey guys, now this is gonna be my demonstration about my project. Now when I put the cup in, it should be releasing the water because of the sensor. So when I put in the cup, it should be taking out some stuff, and whenever I take out the cup, it should be stopping. And now I'm using this to be powered with a 12-volt adapter, which is over there. And that's gonna be my demonstration. Thank you.